Hello, lovely people. How are you doing? Welcome back to another video where we are looking at some more questions on compound angle formulae in trigonometry. So we have this one here where we have to work out the value of this without the use of a calculator. So if I write A and B, this is tan A plus tan B, all divided by 1 minus tan A tan B, which is the expansion of tan of A plus B, where A was 45 and B was 15. So this is tan of 45 plus 15, which is tan of 60, which is equal to the square root of 3. Okay, next question. This one looks a little bit funky because what do you do? Like, what do we actually do? Like, genuinely, what do we do? Well, it's quite sneaky actually. So we can actually turn this into this. So this 1, we can replace the 1 with tan 45 because tan 45 is equal to 1. And then it's minus tan 15 divided by, keep this 1 as it is, and then plus tan 45 multiplied by tan 15. So again, using the fact that tan 45 is 1, we can replace tan 15 with tan 45 times tan 15 because it's still the same thing as tan 15. Okay? And now again, doing what we were doing before, if we say this is A, this is B, this is A, this is B, that is supposed to be a 45. We have tan A minus tan B over 1 plus tan A tan B, which means this is tan of A minus B. And that is tan of 45 minus 15, which is equal to tan of 30, which is equal to 1 over root 3, knowing our exact values, or we can say that this is the same thing as root 3 over 3 by rationalizing. Okay, next, prove the identities. We want to prove that sine A plus 60 plus sine A minus 60 is sine A. So we just use our expansion. So sine of A plus 60, so just doing part A over here. This first bit expands to sine A cos 60 plus cos A sine 60. And then this other one, this sine A minus 60, expands to sine A cos 60 minus cos A sine 60. Okay, so first of all, just to make things a little bit easier, we've got the cos A sine 60 and minus cos A sine 60 cancel. So you're just left with sine A cos 60 plus another sine A cos 60. So this is 2 sine A cos 60. And in particular, we know cos 60 is equal to a half. So that's 2 times sine A times a half. 2 times a half is 1. So you're just left with sine A, which is what we were asked to prove. Boom, boom. We got it. Right. Let's leave some space and let's go for the second part. There we go. Looks so satisfying to do that line. Okay. Right. Now, next we want to show that cos A over sine B minus sine A over cos B is the same thing as cos A plus B over sine B cos B. Right. Looking at this, I'll start with the left-hand side, and what I'll do is I'll add the fractions. So adding these fractions, we get, well, first of all, we can make a common denominator of sine B cos B. So by multiplying the top and bottom of this one by cos B, And for this one, multiplying top and bottom by sine b, the fractions then become cos b cos a over cos b sine b, and that's minus, and then this fraction becomes sine a sine b over cos b sine b. So all I've done is just multiplying top and bottom by their respective trigonometric ratios. And then putting these fractions together, I get cos, I'm going to write it in this order, cos A cos B minus sine A sine B. And that's all divided by sine B, just writing the sine B first, cos B, trying to make it look more like the right-hand side. And the top is actually just the expansion for cos of A plus B. So lo and behold, we've got that there. So that is it for this question. Okay, let's go to this next one. We want to show that sine of x plus y over cos x cos y is the same thing as tan x plus tan y. Well, the top bit, we can expand, if we start on the left-hand side, to sine x cos y plus cos x sine y, and that's all divided by cos x cos y. Okay, so this we can rewrite as sine x cos y over cos x cos y, just splitting up the fraction, plus cos x sine y over cos x cos y. Now, cos y cancel, and sine x over cos x is tan x. And then cos x over cos x, they cancel. Sine y over cos y is tan y. And there we go. We've shown it's equal to the right-hand side. Okay. Next, let me just move this up actually so that we have a bit more space. There we go. Next, I'm going to write in red. I've got cos x plus y over sine x sine y plus 1 is cot x cot y. Okay, so I'm going to start with the left-hand side. So the top bit expands to cos x cos y minus sine x sine y. And that's all divided by sine x sine y. And we are adding 1 to that. Okay. What can we do now? Well, we could actually add this 1 as a fraction. So we can imagine this 1, I'm going to change this 1 just over here in this line to sine x sine y over sine x sine y so that we can add the fraction. So this 1 can become sine x sine y over sine x sine y. So the purpose of that is to make the denominators the same and we can add. When we add the fractions, we end up with cos x cos y, but then the minus sine x sine y plus sine x sine y, they will cancel. So you have cos x cos y all divided by sine x sine y. Now, we've got cos x over sine x. Well, that's equal to the same thing as 1 over tan x, which is cot x. And then cos y over sine y, well, that's again 1 over tan y, which is cot y. Lovely stuff. Let's leave it here for this video, and I will see you in the next one. Take care.